Energy is everywhere. It's what makes things move, change, and happen. Think of it as the invisible force that drives the universe. Without energy, our world would be a very different place. Picture a world without light, warmth, or sound. That's a world without energy. It's the fuel that powers everything around us. From the smallest atom to the largest star, energy is the key ingredient. Energy can't be created or destroyed, only transformed. This fundamental law is known as the law of conservation of energy. It means that the total amount of energy in the universe remains constant. Understanding energy is crucial. It helps us make sense of the world and appreciate its wonders. So let's embark on a journey to explore the different forms of this essential force. Kinetic energy is the energy of motion. Anything that moves possesses kinetic energy. The faster an object moves, the more kinetic energy it has. Imagine a speeding car. It has a lot of kinetic energy because of its high speed. A slow-moving bicycle has less kinetic energy because it's not moving as fast. The mass of an object also affects its kinetic energy. A heavy truck moving at a certain speed has more kinetic energy than a small car moving at the same speed. Kinetic energy is all around us. The wind blowing, a ball flying through the air, and even the Earth orbiting the Sun are all examples of kinetic energy in action. Potential energy is stored energy. It's the energy an object possesses due to its position or condition. This stored energy has the potential to be transformed into kinetic energy. Think of a stretched rubber band. It has potential energy because of its stretched state. When released, that potential energy converts into kinetic energy, causing the rubber band to snap back to its original shape. Another example is a book held above the ground. It has potential energy due to its height. When released, gravity pulls it down, converting its potential energy into kinetic energy. Potential energy can be found in various forms, such as gravitational potential energy, elastic potential energy, and chemical potential energy. Thermal energy is related to the internal energy of a system due to temperature. The hotter an object is, the more thermal energy it possesses. This energy is associated with the random motion of atoms and molecules within a substance. Imagine a hot cup of coffee. The molecules within the coffee are moving rapidly, indicating high thermal energy. As the coffee cools down, its thermal energy decreases and the molecules move more slowly. Thermal energy can be transferred through conduction, convection, and radiation. We experience thermal energy in our daily lives through sunlight, cooking, and heating our homes. Section 5. Energy in the wires, electrical energy. Electrical energy is the flow of electric charge through a conductor. It's a versatile form of energy that powers our homes, devices, and much more. Imagine a light bulb connected to a battery. The battery provides the electrical energy that flows through the wires to the bulb, causing it to light up. Electrical energy is generated in power plants through various methods, such as burning fossil fuels or harnessing the power of wind or water. From charging our phones to powering our computers, electrical energy plays an indispensable role in our modern lives. Section 6. Energy from within. Chemical energy. Chemical energy is stored in the bonds of atoms and molecules. It's the energy released or absorbed during chemical reactions. Think of burning wood. The chemical bonds in the wood are broken, releasing stored chemical energy in the form of heat and light. Chemical energy is essential for life itself. Photosynthesis, the process by which plants convert sunlight into energy, is a prime example of chemical energy in action. Food, batteries, and fuels like gasoline are all sources of chemical energy that we rely on. Section 7. The powerhouse of the universe, nuclear energy. Nuclear energy is stored in the nucleus of an atom. It's the energy that holds the nucleus together. Nuclear reactions, such as fission and fusion, can release enormous amounts of energy. Nuclear fission, the process of splitting an atom's nucleus, is used in nuclear power plants to generate electricity. Nuclear fusion, the process of combining atomic nuclei, powers the sun and other stars. Nuclear energy is a potent energy source, but it also comes with risks and challenges, such as radioactive waste disposal and the potential for accidents. Section 8. Energy transformations from one form to another. Energy can be transformed from one form to another. These transformations are happening all around us, constantly. Imagine a ball rolling down a hill. Its potential energy converts into kinetic energy as it gains speed. At the bottom of the hill, the kinetic energy might be transformed into sound energy as the ball hits the ground. Solar panels convert light energy from the sun into electrical energy, which can then be used to power our homes or charge our devices. Understanding energy transformations is crucial for developing new technologies and using energy efficiently. Section 9. Energy's vital role in our world. Energy is the lifeblood of our planet and civilization. It powers our homes, fuels our transportation, and enables us to communicate, explore, and innovate. From the food we eat to the devices we use, our lives are inextricably intertwined with energy. As we face global challenges such as climate change and resource depletion, understanding and managing energy sustainably is more critical than ever. By exploring alternative energy sources, improving energy efficiency, and adopting responsible consumption habits, we can ensure a brighter and more sustainable future for generations to come.